Okay, a logarithmic form of the equation 4a cubed equals b, where a is greater than 1 is. So we've got some, they look very similar, and it's not hard to see once you do this question where someone might make a mistake. We have to turn this into a logarithm. I think the easiest thing is going to be to actually divide both sides by 4. So you get a cubed equals b over 4. And right away, you can probably already see what our answer is going to be here. So when I go to turn this into a log, so then I have log base a, and then b of 4, b over 4, and it's going to be equal to 3. So yep, right away, that matches exactly what we have. So our next diploma question, if log base a8 is equal to 3 and log base 4 of b is equal to 3 over 2, then the value of log base ab plus log base b of a to the nearest hundredth is. Feels like it looks really complicated, but if we just take each little equation and look at it singularly, it's not too bad. So this first equation will let us figure what a is, first of all. So I'm going to rewrite this as exponential equation. So we have a to the power of 3 equals 8. So then, is it possible to make it so that this has a exponent 3? Well, yeah, this can be written as 2 cubed. So therefore, a must be equal to 2 then. Okay, so that's not too bad. And I'll do the same thing to our second equation, but this one lets me find b. So we'll write it in exponential form. So 4 to the power of 3 over 2 equals b. Now 3 over 2, well, we can square root 4 first, so you get 2 cubed is equal to b, and 2 cubed is 8. All right, so now that we know what a and b are, we can actually go and write what our equation is supposed to be. So log 2, and then our b is 8, plus log 8, and our a is 2. Next, I got to try to figure out how can I write these or make this into some kind of number or constant. And I have to remember that if this base is the same as our base here, so our base right now is 8, then it's just going to be whatever the exponent is. So I can actually write 8 as a base 2. So log base 2, and 8 is actually 2 cubed, meaning this is equal to 3. The second one's a little trickier to see. Like, is it possible to write 2 with a base of 8? And yeah, it actually is. So we have 8 to the power of 1/3. So if we cube root 8, we actually get 2. So therefore, we have plus 1/3. And we add these together, and we get 10 over 3. Now it asks us the nearest hundredth, so that's equal to 3.33. Okay, the next question. An expression that is equivalent to log, and then brackets 2 sine x over sine brackets 2x, where it's between 0 and 90 degrees is. Now this is a double angle identity, so right away you're going to want to go into your formula sheet and actually change that. So we get 2 sine x and substitute 2 sine x cos x. Now if we look at what our possible answers are, we're either left with cosine x or sine x in here. And it looks like we can cancel a sine x, and also a 2 and a 2. So we're left with log 1 over cosine x. Now the problem is none of these actually are like 1 over cos x. Well, we can reciprocate this. So if we reciprocate it, then we'll end up with cos x negative 1, because that will, if we take the negative 1 exponent, it will turn into 1 over cos x. Then we can use our power law, and it becomes negative 1 log cos x. And sure enough, that is right there. Right, our next question. If log base 2 of 3 is a, and log base 2 of 10 is b, then an expression for log base 2 of 90 is. Now the key thing here is all of our logs are 2 in this case, which means that when I'm looking for this, it's going to be like something like log 2 of 90 is going to equal to some kind of combination of 3 and 10. Because if we have the same logs everywhere, then we can just say, so for instance, like log 2 and then something times something, so the somethings are 3 and 10, it's going to get me 90. So we're looking for, well, what combination gets me 90? So like 3 times 3 times 3 times 3, or 3 times 10, or whatever it happens to be. In this case, it's going to be 3 times 3 times 10 gets me 90. So in my logarithm then, I'm going to be 3 times 3 times 10. And the reason this is true is that they're both log 2, so I could just say 90 is equal to 3 times 3 times 10, which we did down here. But everything that I have is related to a log base 2. So I want to keep these log base 2, and I'm actually going to use the product law to split this up. So we get log base 2 of 3 plus log base 2 of 3 plus log base 2 of 10. And then we got to go look. Okay, log base 2 of 3 is actually represented by A, so that's A plus A, and then log base 2 of 10 is B. So then we have 2 A's plus B. So our answer is B.